Hello.
Hi, Diane, Peter.
Good to see you.
Good to see you too. Wait, let me quickly try to turn off my video screen.
You see the sun reflecting in your face.
Oh yeah, yeah.
Mm-hmm.
So let's see, where can I?
Hi, Tom.
Hello, Tom. How are you?
I'm well. How's everybody doing?
Good, good.
Good. So it looks like I'm getting in okay, no problem. So that's good.
Yeah.
That's a good sign.
So now I just need to go figure out how to apply the background, right?
Mhm.
So this is where I am right now. So, good to have these backgrounds.
I like the background. All right. So okay, here's a background.
Welcome to the MIT Club of Germany. My name is Wolfgang Ungerer. I'm the current president of the club, and together with my colleague Peter Clement, we would love to welcome you to our latest event in the series Climate Change Matters, which we began back in October last year, so almost 12 months ago, or in fact, a bit more than 12 months ago. Today's event will be about sustainable manufacturing, and we are very happy to have a great panel, and we will surely have some very intriguing insights and hopefully also a lot of discussions. But before we start with the event, I would like to take the opportunity and briefly say a few things about the club and about today's speakers or about today's moderator. So for those who don't know the MIT Club of Germany, obviously, we are, as all the other clubs, a volunteer organization. We're looking after alumni and also friends of the Institute of MIT. We have about 700 alumni and people associated living in Germany. We have a very active LinkedIn site with about 600, actually 630 connections nowadays. And we have about 200 full members. Each year, our club sponsors a number of events, and we literally just came out of one of the national events, the annual general meeting. It was held in Stuttgart for about 2.5 days. And that's where we typically also inform our members. We hold various organizational matters, like, for instance, electing the new board. And so since this weekend, we have a new board, and our longstanding president, Helmut Lotze, who's been serving the cause terribly well over the last years, has handed over, and I was able to be his successor with a very good team of volunteers. And obviously, we will now try to hold the flag high and organize more events of this kind, but also physical events over the next months and obviously the year. So if I briefly take you through our Climate Change Matters series, this is a series which we felt very strong about. It was obviously a result of COVID-19 not being able to actually have physical events any longer. And so we started a pilot for an online event 12 months ago, and we have by now a number of different formats. So this is not our second, in fact, I think it's our 5th event, and it is considered to be an expert panel event. We also have fireside chat events, which are one-to-one. We haven't yet held speaker events, but that would obviously be the normal speaker event. And we've also had a workshop. And these events focus on climate because it's such a predominant issue of our day, and clearly one that is so broad and so complex that it warrants depth. And so we have been keen to go into different subject areas, such as education, business, organization, policy, and of course today, manufacturing. So this is just a little background on it. For today's event, you will see in Zoom a Q&A box, or a way of addressing us with Q&As. So please use the Q&A box to ask any questions, and we will try to capture them and then relay them to the panelists. And we will do our best. By experience, we can't always answer all the questions, but we will do our best to do so. And so please feel invited to participate, to ask questions, and to see if you can get the answers that you're looking for. So today's event is going to be all about sustainable manufacturing. And we have the big issue about how digital technologies can actually help manufacturing, and especially this, the complexity of manufacturing, become more sustainable, more intelligent, more clever. We have experts from Germany as well as from the US looking at this. And in fact, actually, it is one of the key issues as we now see supply chains, but also sustainable manufacturing, to understand how to restructure manufacturing, both technologically, but also organizationally, because of course, on the supply chain side, we can see a lot of disruptions. And of course, there's discussion nowadays of pulling in supply chains into back into the regions where things are being manufactured, and try to actually connect them back with the manufacturing process. But I'm not going to try to actually explain this. For that, we have our panelists, and it's a great joy now to also introduce our moderator today. Tom is going to take us through today's event. And Tom has a long-standing background in global manufacturing. So he is an industry, he's the global manufacturing industry lead for Avanade. Avanade is a joint venture between Microsoft and Accenture. Avanade, by the way, is also the sponsor of today's event. And so we are very happy to have their support, and Tom's support in particular. And since starting his career in the early 1990s with IBM, Tom has spent close to about 30 years working with manufacturers, helping them leverage technology to overcome challenges which were on the way pretty much at every turn, and enable, obviously, top initiatives to happen. Before he joined Avanade about 3 years ago, Tom was in several high-tech companies, including also Hitachi and Columbus. And so without further ado, I think we have an excellent person who understands the background, the intricacies, but also the practical challenges of manufacturing and of restructuring manufacturing. And so, Tom, if I may, I would love to hand over to you.
Absolutely. And thank you, Wolfgang. I'm really excited about the opportunity to moderate today's panel, expert panel discussion with some really sharp people. I'm super excited about the topic as well. You know, if you look at sustainability and becoming a more sustainable manufacturer, it's not a brand new concept, but even as recently as a few years ago, not many manufacturing organizations had sustainability as a core strategic initiative, or had programs built on sustainability, and you almost never heard of positions like a chief sustainability officer, right? But that's changed in recent years, and manufacturers are really looking at how they can strategically approach becoming more sustainable and responsible manufacturers. And technology plays an absolutely critical role in that. And we're being asked more and more every day from our manufacturing clients, how can we leverage digital technologies to achieve our sustainability and responsible manufacturing efforts? So it's a topic of top interest, and I'm really excited about the day. So I'll quickly introduce the panel, and then we'll get started. So Peter Post is a well-known manufacturing industry thought leader and technology advisor. He has numerous awards, including the German Future Prize from the federal president. And Peter brings decades of experience in research and design, in industry advisory and technology advisory to the conversation today. So he'll get the discussion started, really focusing on how Industry 4.0 technologies can help manufacturers achieve their sustainability efforts. Eric Barnstead will follow. He is a close to 20-year veteran from Microsoft, where he's had multiple roles in engineering, but focusing on automotive and manufacturing industries. He represents Microsoft on several global initiatives, including the Plattform Industrie 4.0 Standards and Architecture Working Group and the Clean and Smart Manufacturing Innovation Institute. And I'm really excited about his views and what he'll share with us on how manufacturers can be collaborative, cooperative, and work together so that the industry as a whole can advance our sustainability efforts. Jose Pacheco will wrap us up with a discussion really around how educators can develop programs that connect manufacturing principles with emerging technologies and are designed to improve sustainability and quality of life efforts. Jose is an MIT Master of Engineering in Advanced Manufacturing and Design. He's had that role for close to 10 years. And in that role, he's led more than 30 projects globally with manufacturers. And he's held multiple positions with MIT, including recently, until just recently in June of this year, as the chair of the MIT Enterprise Forum chapter in Mexico. So again, I'm super excited about the conversation, really appreciate the opportunity to moderate the discussion. We have a great panel. Looking forward to a great discussion. And with that, Peter, I'll turn it over to you to get things started.
So thank you very much. I'm just switching to my presentation. I hope you can see it.
We can, yes.
Yes, thank you. Okay, I'm coming. Thank you very much for this kind introduction. And I'm here as a representative of the Platform Industrie 4.0. So these are not only my ideas, but I'm talking here about and showing the concept, which is already the actual state of discussion what we have in the Platform Industrie 4.0. Let's start a little bit with the introduction of Platform Industrie 4.0. Platform is already now working together since about 10 years, and it is driven by the situation that we know that all with these aspects of digitalization of industry is such a large and such a big thing, which nobody can solve alone. So that means we have to find solutions where all stakeholders coming from industry, from science, from business, from government, from business associations, and so on, and trade unions are taking these aspects together and find ways for the future how we can implement digital solutions so that they are really working on the shop floor level. That is the main task what we are going to discuss in the platform industry 4.0. It's a strong network of people coming from all these different aspects and discussing all these things. We are about 350 members from different associations. But now we are not only working in Germany, we know that sure, industrialization and industrial processes are going to be implemented throughout the world, and these ideas have to be discussed in the worldwide community. So we have connections to US, to Mexico, mainly sure here in Europe, very strong connections to Netherlands, to bilateral cooperations with Italy and France and so on, to the European Commission, and sure in China, Korea, Japan, Australia, here we have activities as well. So this is a very important thing that we see that Industry 4.0 is not only a thing which we are going to discuss within Germany, because digitalization is a thing which we have to roll out worldwide, because the companies which are doing their work are international and global working companies as well. So when we are discussing Industry 4.0, we have a roadmap vision for Industry 4.0, which has more or less three fields of activities. On the one side, it is autonomy. That depends on technological development and security and trusted data infrastructure, digital infrastructure, which is trustfulness and working. We have to build the interoperability with the implementation of standards in integration and integrate decentralized systems and artificial intelligence as decentralized intelligent industrial solutions. But we are now discussing here today the aspect of sustainability. Sustainability in a full view. On the one side, work and education. On the other side, the social participation, to have the role of industry in society in general. But here we are now discussing more or less very detailed the climate change mitigation and the circular economy aspects, and how we can solve such situations with digital tools. So that is what I've already told you is more or less in detail here in this slide. We are thinking that when we are thinking about sustainability, we have to look to the holistic picture. But today we are going here to discuss it in climate change mitigation and the circular economy aspects. And I will go a little bit more into detail. There are a lot of aspects, a lot of things where we are going into really practical details, not only discussion in visions, but going into showing practical examples in many, many industrial applications, and discuss that individual solutions can be generalized and roll out and find scalability aspects to implement sustainable solutions with digital tools in different aspects. So when we are discussing a digital network and sustainable manufacturing, we have found out that we have to concentrate on three paths. The path one is to reduce consumption and to increase impact. That means all these aspects which are coming with energy and resource efficiency should be discussed here. And here we will find first solutions which can be directly applied on the shop floor level. Then switch to path three on the right-hand side. we have to discuss all these aspects which are coming in circular economic systems. How can we work together in circular economic systems? How can we put life cycle management really on complex products? And how can we close the loops finally? And which is here the path 2 is for me the third development level is how can we implement new business fields, new businesses from these? How can we support this with new digital business models in services and new opportunities in this context? Ecological and economical solutions should not be fighting against each other. We have to develop these things together, taking into account the opportunities of digital solutions. So when we are going into these different paths, so next, path 1, reduce consumption and increase impact, then this is one of the most important things which can be implemented directly with specific aspects on taking digital solutions and sensoric measurements and so on the shop floor level to really make not only energy management on the shop floor level, but to switch it to a resource efficiency and even finally come up with a sustainability ledger. That means that we have to take it into account in the financial accounting. CO2 neutrality should be the new normal in future, and many companies are going step by step into these activities. Path 2, what I've already told, is from mass production to transparent service offerings, implement methods which have a view transparency over life cycle management. Here, sustainable twins, digital twins will help us a lot. Material paths, which is accompanying the products throughout the whole lifetime, and to implement really remanufacturing loops and to implement the services which can support these things together with reverse logistics. There are a lot of new business opportunities when you really take sustainability into account. And here we have made rather recent study of 10 assumptions which we have to study, which we have implemented in the platform, which can distribute it as well. How to develop future business models within the context of sustainability. And finally, sharing and networking. How can we build up circular economy, and how can we redefine the networks of manufacturing into these future demand. That means from the proprietary production to shared value added factor, and this is how where we have to implement a new thinking and a new management tasks into our activity fields. So let's come to the end. Many of these things are going to discuss, many implementation fields are going to discuss in the task force of the Platform Industry 4.0. All these things coming from recycling, digital twin, how can we use it? How can we implement sustainability ledger, circular business economy, climate-friendly material, data analysis, AI methods, and so on. These are discussed in different working projects of the platform, and we are going step by step forward. And the main situation, the main aim, the main goal is to find solutions which are really working on the shop floor level, and what we can then show to others that these things are really working, and that we can make spreading throughout all the industry with an exponential growth of all these aspects. So thank you very much for listening to my input. Thank you.
Excellent. Thank you so much, Peter. Really, really insightful, some really insightful information there that I got a lot out of. So thank you. And I think our next speaker, Eric, again, is going to talk about how the manufacturing community as a whole can be more collaborative, standardization, cooperation, and how that can enable the community, the manufacturing community as a whole to be a catalyst in achieving our sustainability and responsible manufacturing efforts. So Eric, I'll turn the floor over to you.
Oh, thank you very much. And thanks for having me on this panel. So I'll get right into it. So let's first define what sustainability actually means specifically for the manufacturing industry. Lots of people only talk about carbon, but really, you know, if you want to be sustainable, you also need to take into account how much waste you're producing, where that waste is going, you know, how much water you're consuming during your manufacturing process, and if you have wastewater, if that is contaminated or not. And then finally, how you're dealing with ecosystems also need to be taken into account. Are you know, having an impact on existing ecosystems? Are you damaging them? Do we need to protect those ecosystems in the environment that you're manufacturing in? So these are all additional considerations, but for sure, the biggest impact on climate change, you know, hands down is the emission of carbon, greenhouse gases. So what do we do about carbon? Well, first of all, you need to define and understand carbon, what kind of different emissions of carbon there are. So there's scope 1 emissions, which are basically generated by burning fossil fuels, right? So basically any time you're putting fuel into an engine and turning that engine on, you're going to create scope 1 emissions. The good news is that that's easy to measure, and more these days, it's also easier to avoid scope 1 emissions by switching to alternative power sources. The second scope are so-called indirect emissions, basically emissions that are produced during the production of electricity that you end up using in your manufacturing process. So switching to a renewable energy provider will, you know, reduce or completely avoid scope 2 emissions. And again, that's relatively easy to measure because all you really need to do is, you know, look at your energy mix, as it's called, you know, basically from your energy provider, you know, figure out how much CO2 is produced from that, and then multiply that by your consumed energy that you can read off your electricity meter, right, during your production process. So again, relatively simple and relatively easy to avoid. And yes, you've guessed it, there's also scope 3 emissions, and these are emissions through your supply chain. So basically goods that you purchase, and then your own produced goods as well. I mean, if you're producing, let's say, a personal computer, that personal computer will be used and, you know, will use electricity by your customers, and all of that will also end up being your scope 3 emissions. And of course, they're much harder to measure because, you know, you really need to have visibility into your entire supply chain and your logistics as well. So unfortunately for manufacturing, scope 3 emissions are the bulk of the emissions that are being produced, right? So, you know, just doing the easy stuff is not going to cut it. You also need to deal with, you know, measuring your scope 3 emissions and then figuring out how to reduce them. And by far the largest impact will be on where you purchase the goods that you use for your manufacturing process. So the raw materials, but also the machines and anything else you use, for example, to build a factory. All of that is by far the largest bulk of scope 3 emissions. And then, like I mentioned before, you know, basically what you produce, if the goods that you produce are actually, you know, producing emissions as well, that needs to be taken into account. And then again, your supply chain and your capital goods, as I mentioned. So all of it needs to be taken into consideration. And CSEMII in the US and the Platform Industrie Forum in Europe have been collaborating for some time now to build standards and infrastructure to measure Scope 3 emissions. And only through collaboration and standardization can we make sure that we end up with a consistent reporting infrastructure, and to avoid things like double counting, where two different companies claim the same emissions, and confuse the statistics. So one of the major contributions that the Platform Industrie Forum has made, and also which is being adopted by CSEMII, is a so-called asset administration shell. It's currently being made an IEC standard, so it's standardized. Spec is freely available for download, and fundamentally, it's a vendor-neutral asset sharing service. So it works on any platform. It's not specific to any particular company's technology, and you can think of it as a container, like a shell around data that describes your asset, right? So if you're producing an industrial robot, let's say, and you're creating an asset admin shell for that robot, and then making that available somehow to your end customer, then that end customer is going to be able to get the information out of the asset admin shell regarding that industrial robot, how big it is, when it was made, the information model within the robot. So during the operation of the robot, a standard like OPCOA is often used to define the data that the robot provides to the manufacturing system, and so on. So all of that can be used together, and the asset admin shell is the container, right? There's open source implementations of the asset admin shell. There is a consortium called the Industrial Digital Twin Association, IDTA. It will also produce sort of official open source reference implementations that people can use. And finally, the format of the asset admin shell is another standard called OpenOffice XML. So similar to your Microsoft Word or Microsoft Excel files, the asset admin shell uses the same standard. It's basically a zip file with an XML file describing the content. So it's relatively simple technology, but that was by choice and on purpose to make it simple to integrate into existing systems. So now if you think about using something like the asset admin shell, you may find that you won't be able to reduce or avoid all of your emissions, right? So then what do you do? In the manufacturing process, let's talk about steel production or cement production. That's inherently carbon intensive, and it's going to take years to offset and reduce those carbon emissions. So in the meantime, what has become one of Europe's largest carbon capture and storage solution is a project called Northern Lights. And again, several companies in Europe are participating. And the idea is that carbon intensive industry production processes capture their carbon, make that available in a port anywhere in Europe. And then there's going to be CO2 tanker ships visiting those ports, picking up the carbon and bringing it to a CO2 storage facility in Norway. And from there, it's pushed into a pipeline and sent to a 100-kilometer distant hole in the ground, basically on the sea floor. And about 3 kilometers deep, there's a CO2 storage area that was identified through seismic analysis, and several additional storage areas are getting identified as we speak, such that this solution can scale, and then the CO2 will be stored there permanently. What's important here is that this CO2 is not getting used for anything else. You know, some people say that there's a inherent danger that the CO2 will then become you know, available again to oil and gas drilling operations, et cetera, et cetera. That's not the case. The Northern Lights project is 100% storage for good. A similar effort, although less efficient, is a technology called direct air capture. So it's like a small chemical plant that captures CO2 directly out of the ambient air and makes it into a liquefied state, and then again it can be stored somewhere, like for example in the Northern Lights project. It just needs to be picked up from where it's actually getting captured. So there's an inherent or there's a huge, let's say, new industry forming right now for carbon capture and storage, and these solutions will become widespread. And you know, your support in making these reality is definitely a necessity, so everybody can do something regarding CO2 capture, and also you know, avoiding CO2 in the first place, even as an individual. But if you're a manufacturer and you're producing CO2, there are ready-made solutions available to you that, you know, you can use in a manufacturing process to reduce CO2 and to capture CO2 for later storage underground. And with that, I hand it back over.
Excellent. Thank you so much, Eric. And that brings us to our final speaker. And again, Jose will spend a little time talking about how educators can help in the journey to becoming more sustainable manufacturers. So Jose, looking forward to hearing your discussion.
Great, thank you. Appreciate it, Tom, and everyone else, and everyone who is here with us. I'm excited you're sharing this time with us. We know your time is valuable, and so I'm here to summarize and kind of put together a kind of a timeline of how we think about education within the timeline of manufacturing, right? And how we as suppliers, if you will, to the industry can do a better job. Because I think we supply not only, obviously at the research universities, materials and knowledge, but also, very importantly, knowledge and talent. And the talent are obviously our students that will graduate every day, and that will have a significant impact in the implementation of everything that we are talking about today. And so with that, let me take the next step. And as Eric already shared, we have to first define sustainability. And the way we think about it here, at least within the Department of Mechanical Engineering and the MEng, is that we have to significantly reduce or ideally eliminate the use of carbon, very specifically that carbon extracted from the earth and emitted into the atmosphere. I think we have to be specific, as you'll see, because how we teach and how we go about teaching depends entirely on what it is that we are trying to measure or what we're trying to eliminate. And second, as already mentioned, is this reduction and elimination of the use, especially of water and fresh water. And then lastly, the reduce or eliminate the use of new or undeveloped natural ecosystems, as we call it. And we think that's very important. I do want to acknowledge something that Peter Post said, and I think sustainability is evolving in its definition as well, as the impact of climate change is having a significant impact on social inequity. And so that's something else that I think we need to be mindful about. But with that, let me talk about how it is, what it is that we teach. Now, when we think about teaching about manufacturing, we generally start about production, right? And so everything that we focus on initially, at least in the introductory courses, are how we reduce cost, how we increase the rate of production, right? Or reduce the time of production, another way of thinking about it. How do we improve quality? And of course, how do we increase the flexibility of the manufacturing assets that we have? However, over time, I think we've also begun to see that it's not just about cost, rate, quality, and flexibility, even though those do remain the cornerstone of manufacturing education, is we have to take a broader view of the manufacturing firm. And so we started seeing that it's not just about the production area, but also how it is that we compete, as firms. And so over the last, especially 30 years, as our previous speakers have noted, we've started thinking about, okay, how do we compete on service, on technology and innovation, and design, of course. That's perhaps one of the more recent innovations in competitiveness for manufacturing, and lastly, reliability. Right? And so now, as mechanical engineers or engineers in general, what we teach in the programs are around not just, again, production, but these other areas. And how does that then become classes? How do they become curricula? And we think that's important. And so we have to put a layer on top of what we just spoke about and say, well, there's 4 areas that we generally think about teaching in an interdisciplinary program like the MEng. Obviously, we have to think about the physics. Then that includes the processes and machines to make things, right? But then we also have to think about the design of the product that we are producing. And think about it from a perspective not only of the function, but also what is it made of, right? And then how do we design the systems themselves, not only in production, but then, as already mentioned, in supply chain to get the product to market, as well as get the raw materials into the plants. And I think this last piece is perhaps one of the most ignored, perhaps, in manufacturing education, which is about the management. It is about people, after all, not just machines, that are making the decisions of how it is that something is made, right? And so when we teach about manufacturing, we then put this layer of sustainability on top of it to answer these, I think, 2 key questions. How do the tools that our previous speakers have talked about affect the competitive dimensions we just reviewed? And then what is the product local? And what we mean is, the individual product and the overall life cycle sustainability footprint of our products, right? Essentially, we're trying to understand what is the net new carbon that we're using, including energy, water, and environmental usage. Right? And so those are the questions, I think, that we have to answer. And if we're able to do that, then, the individual technologies themselves are just that. They're tools that we're able to understand how they're going to impact the competitiveness of the firm, the manufacturing firm. For example, time to market, right? And so we have to go back to that. And so how we teach is, I think, the most effective way of teaching sustainability is not to add an additional class, not to have, a separate class, but integrate it into the curriculum. How it is that the carbon footprint of the processes that we're using is impacted. What are we thinking about the design, not just the materials and the form and function, right? But also the overall life cycle of that product. We have to teach that within those courses. Manufacturing systems, how does, as already mentioned, the supply chain and the factory system use environmental cues or environmental resources. And then lastly, so important because the engineers that are starting to, in manufacturing engineering, become leaders of firms. How do we think about the people aspect of it? And how do we think about the talent aspect of that, right? And so it's within these overall curricula that I think we have the most impact. And I'm not going to go in depth into this methodology, except to say that, you know, we have to think about at each step from inspiration when we think about design, right? In meeting customer needs, all the way to distributing and then end of life cycle, about different ways of and the environmental impacts of the design, the production, the management, and lastly, the education aspects of what it is that we're talking about. And we'll talk more about this in the Q&A, right? And so, but this last piece I do want to emphasize around, and it's already been talked about by Peter, that lifelong learning is key to sustainability because there are new tools, new methodologies, new materials that are being used. And so as a result of that, this new knowledge has to be implemented, and the only way to implement it is to instill it in the educational systems, both at the university level, but then on an ongoing lifelong learning way. And from an educational standpoint, we then have to think about how we adapt these educational models to collaborate with industry to do it better. Because as mentioned before, their industry has roadmaps about, you know, better sustainability. We within universities have to understand what those roadmaps look like and not only help in developing those roadmaps, but also educating our students within that roadmap, and then also providing an on-ramp for future online learning. And so, or for future learning. And so one way that we've started thinking about this is obviously with COVID plus, as we're now calling it, right? How we work, it's doing digital enhanced or digital enabled or hybrid education. And we've created our own around that as well. And then very briefly, of course, as an example of blended program, where we now are able to take advantage of these digital platforms. It's wonderful to do the Zoom aspect of it, but what Industry 4.0 is now allowing us to do as educators is have a much more direct connection to the industry, because now we can get data that, you know, we have to make up in classes. We actually are able to collaborate. And so we can do this blended program where we're able to get real-time data, do real-time education via these video platforms, and then bring people onto campus or campuses around the world to discuss in depth the implementation and the meaning of what we're doing, right? What does it mean to use these tools, and how do they impact not only the sustainability aspect, but I think very importantly, this social inequity question that we have. We have a couple projects. So part of what we do within our master's degree, of course, is we work very closely with industry in these 1 year long projects where we have project objectives, which are generally focused on reducing some, you know, or impacting one of the competitive criteria that we discussed earlier. What we're realizing now is that that's not enough, right? If we're going to teach sustainability within the whole curriculum, our projects themselves also have to have objectives that focus on sustainability, right? And so in black of these two projects, you can read them yourself, are the objectives that are kind of the classical objectives. But then, for example, the reduction of electricity by a goal, a quantitative goal is important. So we started thinking about adding that and working with companies as a project objective within the overall project, right? Or reduce the transportation miles to reduce fuel usage and materials by a certain percentage. So that's the kind of integrated thinking that I think we have to do. And so with that, I'll turn it back over to Tom and my colleagues and look forward to your questions.
Yeah, absolutely. Thank you so much, Jose. Some really enlightening stuff that I enjoyed. So I'll ask Peter, Eric, and Jose if we could all turn on our cameras and microphones, and we'll address the questions that have come up. And there are quite a few, so hopefully we'll be able to get through all of them. I'll start with one that actually was the first question, and I think it's a great one. I may give a quick point of view and then open it up to the panel. But the question is, what are the largest challenges for manufacturers to reduce emissions? And I'll almost take a quick stab at this from the manufacturers themselves perspective. So I think there's kind of a few key challenges we see as we engage with our manufacturing clients. The first is this truly an executive priority, right? If it's not a top level priority for the executive team, it's going to be hard to get buy-in from the company and really achieve those objectives. So we have to look at the company and understand, is this something that's really strategic to them? If not, they're going to have challenges overcoming those and meeting those objectives and overcoming the challenges they have. So it's got to be a strategic top-down initiative for the business. And then the second kind of piece of that is where we're often, even when it is strategic, we're often asked, where and how do I get started, right? I mean, Jose put a slide up that had 50 different potential technologies that might be beneficial in enabling companies to meet their sustainability objectives. Oftentimes companies will say, I don't have skill sets there. I don't know what to measure. Are there places you can help me get started? So I think those are kind of the key things is, first of all, make it strategic, then look at the capabilities that you have and the gap in capabilities of where you can go enable technologies to help you to overcome those challenges and meet your sustainability initiatives. So, but I'd love to hear the panel's thoughts on that question as well, because I think it's a great one.
So if I may add, Tom, I think you're right on. As you said, having the top down, that means there's buy-in, right, from management about these concepts, whether it's the tools or just the general concept of reducing our, carbon emissions, et cetera. Let me add and then that it's got to be strategic. Let me add this concept that it's also middle in, and this is where I think education comes in. One of the largest challenges is translating the strategic vision or strategic desire of reducing emissions into the everyday, right? And so the design of product, design of manufacturing system, et cetera. And so while there may be a commitment, middle in means that the people actually doing the work also have to have a sense of what are the individual key goals that we have: reduce energy, reduce water, et cetera, right? But then we also have to teach them how to do that, or what are the current methods that we understand to do that, and how are the tools helpful to that, right? And so that I would add the middle end part as well.
Yeah, I love that. And I'll even almost take it a step further, right? To engaging across your entire organization. I mean, if we look at manufacturers, the frontline manufacturing worker is one of the most disengaged workers in the workforce. So how can we find ways to help them feel like they're more involved in the strategic direction of the company? What can we do to help them? Because sustainability matters. It's important to them on a personal level, and it's important that they see what the company is doing. So how do we get their involvement? And we've done some really simple things. We created almost a gamification app that aligns what the corporate strategic sustainability objectives with a way for every single employee to submit ideas. And if your idea wins, you get some points, and the more points you get, you can get company shirts and things like that. But again, it does two things. It helps us put the processes and solutions in place to meet those objectives. and it engages our people to help them be more active in the process, right? So.
I would like to add a comment in this context, especially in this first question: what are the challenges for manufacturers to reduce emissions in combination with these educations? On the one side, the very most important thing is to have a transparency, what's going on really on the shop floor level. For example, we are a supplier of pneumatic components which are used in industrial production processes. The importance is to have an overview is if there is any leakage of compressed air somewhere in the factory, and then you can have to detect it, and then you have to put on the right measures. For example, and all these things need sensoric implementation, and this needs specific implementation of evaluation algorithms, which gives the plant controller and the worker, even the worker on the really an insight what's going on in his plant, what is going on in his specific system, so that he can react. For example, we have a rather new implemented factory here nearby where we have implemented the energy transparency system. And this energy transparency system gathers all the energy consumers and gives an overall picture where is what kind of energy used, and then you get the implementation of control instruments. And this is all be done with digital tools. And one more aspect, especially with these learning things and the education, we should find more and more ways how to implement learning aspects in the overall work of the people. Here in this already mentioned plant, we have implemented a learning factory where the people can come, have short seminars for a few hours and so on, and go with this knowledge back on their working place. And here we have some seminars, especially covering all these aspects of energy efficiency, and so on.
Yeah. If I could add to Peter, what Peter said, and emphasize one point that I think is so important and it's new, I think, of learning within the work, right? It's not new when we think about Kaizen, right? For example, and Lean. What is new, however, I think, and not to give nightmares to our alumni who are here, the way we think about exams here on campus is that they themselves are a learning opportunity. We teach through the exams as well as, as see what we've taught. I think this concept of learning through the work is a challenge for us in university, a good challenge, because then it becomes interesting, not boring, right? The whole aspect of learning, and relevant and timely. Like that's the golden ticket right there for education. And I think we're just from the universities or the educational systems perspective, thinking about how do we collaborate on that. And to anyone here on the panel and anyone listening, we're really interested and excited to test out experiments around that. But I think that's one of the key challenges for universities and for us as society to figure out.
I'll move on to the next question, which is what are the central motivations for companies to include sustainability as a target, especially at the management level? Does anybody want to jump on that one?
Maybe that I start with to try to answer this. The main motivation for companies, it's that they are personally convinced that the investment in such solutions for sustainability is an investment in the economic sustainability of the company itself. And this is from different reasons. One reason, for example, is if a company will not show their people what they are doing in these sustainability aspects, nobody will be a worker in such a company in the future. And if you are not showing your customers that you are good on the way in the sustainability aspects, nobody will buy your products. Together with all these aspects which are coming from legislation and society and so on. And so, for example, in the context of our company, in our corporate strategy, we have implemented these directly in the main corporate strategy. That means we want to increase the productivity of our customers, sure, yeah? And thereby create their scope for sustainable development of the environment, economy, and society. That means sustainability needs to be implemented in the more or less strategic demands of the top management of the company, and so that everybody can work with this, even on the shop floor level. One example, for example, the company Bosch, they had met this from the management, top management, and implemented throughout the company, and there was a lot of activity started from this.
Yeah, I think that's a great point, Peter, especially about that we hear about the war for talent, right? Manufacturing lags other industries in attracting top young talent, especially. And you're right. People are not going to work for an organization that doesn't have transparent sustainability goals and can prove that they're working towards meeting those goals. So using that as a way to go out and attract and retain the top talent that they have is, I think, is a super important component of the sustainability program for a manufacturing organization. Jose?
Yeah, if I may add, it's definitely management's kind of responsibility, but I think, and this relates to another question that I think is often asked is, who in the organization, is it the executive board, the CFO, the CEO, the sustainability officer, et cetera, who's responsible? What we found is ultimately it's the board's responsibility, right? If you have board commitment, then yes, everyone is involved, right? But it has to, I think, reach the board level in order for it to be a maintaining activity. And I think that's where there's a lot of activity in reaching the boards and making sure that they have that commitment. Yeah,
and thank you. Actually, Jose, that was one exact question that came up. So, who has responsibility? So I appreciate your answering that one for us already. So.
Maybe that in education, the sustainability aspect needs to be focused on the board members first, and then on the workers in the second step.
Or let's do it both, right? I mean, hopefully the people we're educating now, the 22 to 28-year-olds from master's and PhD programs will be board members, but it's too late, I think, if we wait for them to become board members in 20 years or et cetera. But you're right. I think there is an opportunity there that I'm actually thinking we may have a new program for.
And I would like to add one comment. That is, we are now here in Germany discussing together. We are going on starting a new project together. With this aspect, there should be no conflict between economic and ecological goals. These goals should go step by step together in a holistic view of the overall system. And what is supporting such an holistic view, and how can we support such a holistic view with digital tools as well? That is one of the most important things which we are discussing in the task force of the Platform Industrie 4.0.
So hopefully, I'm getting a bad internet connection message. Hopefully folks can still hear me. If not, I'll ask Peter to maybe jump in. But and Eric, I might steer this next question towards you, which is, how can digital technology help address Scope 3 emissions in a global supply chain?
Right. So similar to what I already said in my presentation, one of the major things that will help us really make traction on Scope 3 emissions is the use of open standards, right? The use of open standards gives you interoperability, gives you consistency, gives you the same measurement at the same time for the same type of emission. And then, we really need to have a government-sponsored carbon trading platform, similar to what the EU already has, but expanded in scope, where things like carbon capture and storage are also taking into account, right? So it must be harder for people to purchase carbon credits, and it must be easier for people to actually reduce and store their own emissions by themselves. And this way we can really make progress on the 50 billion tons of CO2 that we all unfortunately have to deal with on an annual basis.
Yeah, great. And I love it. And, I think, the other kind of component that we talked about is, we have to have standardization on what we're going to measure. And then digital technologies, things that Peter mentioned, right? The artificial intelligence and digital twins and machine learning and supply chain twins, big data. These are all things that now allow us to go out and measure and do the what if planning. And again, the other component of that is let's do a realistic check of what our capabilities are there and figure out which one of these measurement tools makes the most sense for us to get started. So I think that's, Eric, I love it. Let's standardize what we're going to measure and then apply the right tools on an individual company by company basis to go measure those.
Yeah, and I mean, fundamentally, the Platform Industrie Forum and also CSEMII in the US have been doing that and defining these industrial digital twins, right? With the use of open standards like OPCOA and the asset admin shell, right? But OPCOA now is commonplace. It's used quite a lot, especially in net new deployments, greenfield factories. Brownfield is getting retrofitted, or adapter software is put in place. So that's all goodness, and it's really taken off, especially in the last 3 years. The asset admin shell is still relatively new. More adoption is required. And the asset admin shell really only works if your entire supply chain uses it, right? I mean, that's the thing. You can't just use it by yourself and it'll work. You really need to have your supply chain play along. And this is, I think, the biggest challenge of getting everybody along your supply chain convinced to use this technology, but at least it's an open standard, doesn't belong to anybody, right? It's worse if a particular manufacturer end user demands a proprietary format, because then that supplier will need one proprietary format for one customer and another proprietary format for another customer. That doesn't scale, right? So using open standards is the key. That gives you interoperability, and we definitely need this when it comes to actually quantifying Scope 3 emissions.
And Peter, well, it looks like you have your hand up, and that's good because the next question was addressed to you. But if you want to add to Eric's comments, that's great. And then I'll get to the next question. Like I said, that's addressed to you as well. So.
I would like just to support what Eric said. The implementation of the asset administration shell as a general idea to make the interoperability between industrial components and processes throughout a lifetime is one of the most important things. And here we have a lot of solution methods which we can apply to our problems and will help us to solve future activities. And we have to implement it and try to find best solutions taking the standard of this open standard of the asset administration shell, a very good opportunity in this case.
So, Peter, like I said, I'll give you the opportunity to keep the stage. And the next question is, how does Platform Industry 4.0 influence cost and time to market?
Without Platform Industry 4.0, we don't have a chance to have the right efficiency and the right cost level for bringing products to our markets. That means digitalization in industrial processes is one of the most important basics to be successful in future. If you do not implement digital processes and digital solutions, you will not be successful. And here, especially in this context of sustainability, we are thinking about digital solutions applied to questions of sustainability. And here we have very, very good and strong and helpful tools to give solutions for these very difficult answers. But the main thing is, without digital solutions, without the implementation of digital industrial process, you will not be successful in future industrial processes.
And Jose, did you want to add a comment?
Yes. So I think the question itself is exactly on point, which is, how do any of the tools, Industry 4.0 being a set of tools and methodology, affect time to X, right? Time to market, obviously, is important, but how does it reduce time for production? How does it reduce, et cetera, et cetera? And I think that is, again, going from the middle in education, one of the key concepts of in an application for everything that we do. While we're currently in the Industry 4.0 kind of wave, right? There will be more technologies, there will be more waves coming. And so this is why it's so critical to, at this point, involve industry in education with the sustainability mindset, because whatever the next wave is going to be, we have to continue educating around it, both the current, but I think it's also important not to forget, that is the current students, it's important not to forget, again, the workers that are already in industry, right? Because they have such knowledge of the processes, everything that, again, we teach around lean or Kaizen or whatever, for those that might remember STM, they have these concepts, but what's new is the tools. And so how do we help them adapt the tools to that? And on a reflection, as long as I have the stage here for a second, is one thing that has pleasantly surprised us in the online education aspect of this, of what we've been doing, is that there's two peaks of learners. There's the kind of 22 to 28-year-olds, which is a significant peak, but then we then have a second peak of people in their 40s. And it's kind of the decade of the 40s. And I think in part, we're seeing obviously those that are interested in kind of the new coming in from university, but then also people that are already in industry, trying to figure out what's new and how do I apply what I have and marry it with kind of the new things that are coming out.
Yeah, super interesting and a great point, right? Is that we do have so much knowledge and so much thirst for knowledge in the manufacturing organizations around the world. So let's enable them to develop those new skill sets, to develop that new set of knowledge that they need. And I'm going to keep you on the stage because I think I really like this comment and question, which is, so the comment is, it's great to see the focus on the circular economy and remanufacturing discussed. MIT Center for Policy Alternatives conducted a number of studies, DOE funded in the late 70s and early 80s on the global remanufacturing industry, but it's hard to find the publications in the MIT libraries now. is the MIT ME department teaching about the benefits of product design for remanufacturing, for the infinite product life, right? So I love this question because it does, the circular economy is really a hot topic in manufacturing right now, and remanufacturing and enabling end of life that doesn't cause waste, et cetera. So Jose, I'd love to hear your specific answer to the specific question about what MIT is teaching, but then also the panelists in general about circular economy and remanufacture.
Right, sure. So always dangerous to talk about what colleagues are teaching. And so one of the safest answers is, I'm not sure about specifically infinite life, but what I do know in the current area, especially around design, one of the things we've been thinking about from sustainability standpoint, and that I've seen as in different classes, as I mentioned in the curriculum, is this focus on the modularity and sustainability of modularity. So one of the issues, of course, that we're all familiar with in kind of a business model aspect is there's kind of this built-in business model of replacement, right? That's how you think of the iPhones, right? You have an iPhone 8, you need an iPhone 13 now, or iPhone 11 to iPhone 13, I think it's better put, because the modularity is not there. There's very little to replace, or you can replace. But I think these business models and the design of business models that's allowing the upgradable car, right? Tesla is perhaps a great example of this, the most iconic one, right? But then there's a software aspect, and then there's some modularity. What can you then replace within the kind of infrastructure of your product, whatever that might be, so that it has a longer life cycle? So you could, still have you could have an iPhone 8 probably that's doing really well if you could replace, for example, the chip, right? And you wouldn't have to replace an iPhone 13, right, et cetera. So this concept of modularity, I think, works really well as well with this concept of data interoperability. That is part of, as Peter has discussed, part of Industry 4.0, because then it does make sense to replace components in a way that is more sustainable over time. And it's not necessarily a bad thing in terms of the economic sustainability of the organization, because now that we know companies also compete around service, around reliability, around the ancillary products, around the core product, you could actually develop a whole set of business models that I think could be very profitable around modularity. And we see this in the computer industry, how revolutionary that was in the 70s and 80s, and what we're used to now.
There's also the aspect of legislation, right? So, I mean, the right to repair bill, I think was recently launched in the US. I certainly read about it. And also, quite frankly, the user voice makes a big difference. So it's your choice what you buy, right? And, it probably makes sense to buy a higher quality product and not replace it as quickly, right? And this is exactly what people should be aiming for. I mean, there is a certain culture that has emerged in the 2000s where things were readily built for disposal, right?
Mm-hmm.
And that needs to be reversed, right? And I think legislation will help there, because again, something like the right to repair bill also mandates different designs, right? Designs that allow you to what Jose just said about modular designs where components can be easily upgraded, and not the entire thing needs to be upgraded, but also building them in a way that allows serviceability.
Yeah, I think that's a great point. And there's actually quite a few questions around this kind of common thread with end of life and obsolescence and right to repair. And I love that. So it's obviously a super important topic. And one thing I saw that did interest me as well, I guess two, you're right. The consumer ultimately will, I think this is an area where the consumer ultimately is going to really drive the behavior of the manufacturer. And as consumers, demand more options at end of life than come pick this up and throw it in a trash bin or whatever it might be, manufacturers are going to start building products that the consumers have options with. I can return it for a new one, or I can recycle it, whatever it might be. So I do think consumer behavior is something that's really important, and I think we can help influence consumer behavior, right? We can impact that. And then another great point was, a lot of manufacturers don't know what they have out there, right? We've got 30 years of products in the field. So can we come up with better strategies to find end of life options for those as well? Sorry, Jose, it looks like you had a comment.
I was going to emphasize exactly what you said, influencing consumer behavior in part by giving them the information, right? For example, I just noticed, had to take my first flight recently, and when I was looking at Google Flights, apart from everything that they usually give you on schedule and cost, they now tell you how much carbon emissions that flight's going to take and they rank them, right? That actually made me stop and think two things. One, do I really need to take this flight and emit that much carbon? And if I really do need to do that, then should I choose the one that's emitting 30% less carbon, even though it's $5 more, right? And I think in part it's also having that transparent conversation, I'm going to say, in transaction with the consumer, saying we are making strides and here's how we compare. And that's also new in terms of sustainability, involving the customer's perspective, but also giving them a choice at the point of purchase around sustainability.
So one additional aspect that is already commonplace for some products, for some consumer products, is energy labeling, right? So you get a label on household goods, how much energy, how much water they produce. Similarly, I remember back in the 80s, the Energy Star on every PC boot, what was that Energy Star thing? Well, actually, it was to do with how much electricity that particular computer used. And I mean, those kind of government-sponsored initiatives need to be accelerated, including like a carbon footprint legislation. But unfortunately, first we need to figure out ways, how to measure the carbon footprint before we can put legislation around it. So I think more work needs to be done there. And once the technology is in place to really accurately measure the carbon footprint of a produced product, the legislation needs to follow to to encourage building products that are either carbon neutral or even better, carbon negative.
I would like to add one idea that especially what is always already discussed with this aspect of the asset administration shell. The asset administration shell is giving somehow a concept of a lifelong model, which is intrinsically continuously going with the product throughout this whole lifetime, especially when you are looking about in industrial products. But no, it can be developed in such a way because lifetime aspects are implemented in this. And this takes the advantage that the provider of a product or a distributor of a product can look what its product going to do in somewhere in the production processes or in the use at the customer, and making somehow things with the long data which is gathered by the product. And these things we have to think about. How can we implement such things and combine it with service software as a service or service structures and new service models which are used together with new products, because we have an internet representation with it asset administration shell, which covers the whole lifetime of such a product.
Excellent. So I think we're about out of time for questions, and I know Peter Clement wanted to spend the last 5 minutes or so wrapping us up. So Peter, I'll go ahead and turn the floor over to you to let you close the session out. And again, I've had a great time. Awesome panelists. I always enjoy hearing the perspective of really smart people. Great questions. So thank you so much for this opportunity. And I'm glad to continue the dialogue if anybody wants to reach out to me directly after the session. So thank you again. And Peter, the floor is yours.
Okay, thank you, Tom. Hope you guys can see me and also hear me, of course, as well as my slides. So I try to close us out first because we were talking about the CO2 footprint. Yeah. So there's an MIT study that actually measures how much CO2 footprint a Zoom meeting has. Yeah. And so what we're actually doing, we are actually offsetting this event accordingly. So actually this event is carbon negative. Yeah. And we do this for all our events. I think that's just what we need to do to be consistent with our mission to make the world a better place here at MIT and at the MIT Club of Germany. I would like to thank our contributors, Tom, Eric, Peter Post, and also Jose. So you guys will all receive a climate action certificate from us, yeah, for your participation. And then next time you fly, Jose, yeah, maybe you have already something on the bank, so to speak, on the CO2 bank you can draw on, yeah. And that's actually used for a reforestation project in Germany, so a kind of nature-based solution, so to speak, if you want to. Yeah, so thank you again for the panelists and our moderator. It was really great and I enjoyed it a lot. Then I would also like to quickly thank our supporters, our sponsor, Avanade, of course. But as you have seen, there's a lot of different initiatives and programs at MIT that contribute to the success of this climate change matter thing. So thank you to our supporters again. And then the last slide, thank all our guys who gave the participants, you guys who joined and invested some of your valuable time on the morning or evening or wherever you are around the world and listen to our panel. So that's actually the last virtual event for this year for the MIT Club of Germany. As you can see here on the list, we have already some topics locked in for next year. So please stay with us. You can follow us on LinkedIn. We will also upload the recording in the next couple of days on YouTube. You can obviously then also look on our website if you're interested. And with this, I would like to close out the event. Thank you very much, all of you, for sharing this time with us. And hopefully I see you next time for another event in our Climate Change Matters event series. So have a nice evening, day, or morning, wherever you are. Bye.
Bye. Thank you, Peter.
Bye, everyone. Thank you.
Thank you.